things that are not caused by something. For instance, if I made the joke last week about the more ice cream that you eat, the more that it rains in another country. Nigeria, right? Well, that has no effect there. Is there a chance that if we all have an ice cream party, it rains in Nigeria? Well, of course there is. Like, there's always a chance for something to happen. Just like there's always a chance, like, something good happens, something bad happens. Coincidences, right? But we can't always make something a causation piece. The way that we determine if something is causation versus just association is by measuring the correlation between those numbers. Now, if you think back to Friday, we talked about correlation coefficient. Do you guys remember that? And that was when we had the numbers, and we had all those dots on the graph. We graphed it all, and we were trying to see, was it close to the number 1, or was it close to the number -1? And the closer it is to 1, the higher likelihood it is a positive correlation, or a positive causation. The closer it is to -1, is either a higher negative correlation or a higher negative causation. Does that make sense? The closer you get to the number 0, the less connectivity there is to it, the more just random acts that it is. You guys follow me so far? And so correlation is measuring how much causation actually takes place. Katie, please stop doing that. Follow along. Causation means that one thing causes another. You hit your finger with a hammer, so your finger swells. Your finger swelling is caused by the hammer hitting it. We're all okay with causation. Correlation is the relationship between the two things. A positive correlation means when one thing goes up, the other goes up, and a negative is when one thing goes down, the other goes down. If we want to make this more of a mathematical term, it's the way that x affects y. X is your independent variable, y is your dependent variable. So we're trying to figure out which one is causing it to happen. Can you tell the two apart? The temperature outside and ice cream cells. Well, correlation, they are related, but the weather does not cause the ice cream cells to increase. Do we agree with that? Is there a chance? Yes, we like a colder snack when it's hot outside. But nowhere in there does weather actually make you go out and buy that ice cream. If you get your tonsils out, that might make you go buy ice cream because you can't eat any other food. Okay? The number of firemen fighting fire and the size of the fire. The correlation, the bigger the fire, the more firemen. However, this doesn't mean that bringing more firemen will cause the size of the fire to increase. Now, studying, I think we've heard this one a million times, right? By not studying, it doesn't mean that you're going to fail the test. It just means that you could or could not do as well. We oftentimes like to tie it into it, but it doesn't mean it's a definitive answer every time. And then the last one is exercising and burning calories. Okay, so this is back to Friday. Correlation coefficients are used in statistics to measure them. We use the letter R to represent correlation coefficient. Does anybody remember what button we have to turn on our calculator in order to make this work? Does anybody remember? We did it on Friday as a class. Katie, what was it? Second, and then what? Second, 0. What is the word right above the number 0? Zandon? Catalog. So you're going to hit second, 0, which pulls up your catalog. And once you've pulled up your catalog, you're going to scroll down to what word? Peyton?
Diagnostics on.
Diagnostics on. So it's second, 0. We'll go ahead and do this real quick just to practice it. So everybody hit second, 0. It's going to pull up your catalog. And you're going to scroll down until you find the word diagnostics on. Diagnostics on. Brian, I will have a calculator for you for your test on Thursday, but I'm going to just turn them all in and then I'll pull out a few, okay? And once you get to diagnostics on, you're going to hit enter. You're going to hit enter again. And what should it say on your screen at this point?
Done.
Done. Very good. Now, here's what I want you to do. Go to Stat. Click on Edit. So Stat, Edit, and now you should be at your table page where it has L1, L2, L3, L4, L5. Everybody's there. Okay? I just want you to come up with 2 values for the X and 2 values for the Y. I don't care what they are. So 2 for L1 and 2 for L2. I could care less what they are. 2 for the L1, 2 for the L2. Literally just make up any number you want it to be. Okay, once you typed in those 4 numbers, you're going to hit stat again. And once you hit stat again, you're going to go to the right to where it says CALC or calc. We're going to scroll down to number 4 that says lin reg. Lin reg. Click enter. Scroll down to calculate. Hit enter on calculate. And now, what has it added to your chart? R squared and R. We are looking at R. Let me repeat that again. We are looking at R, not R squared. We are looking at R. We're looking at R, not R squared. Excuse me, I have to sneeze real quick.
Bless you.
Thank you so much. Appreciate it. Okay, now, from that R section, you should have a really long number. Maybe not. Maybe you just end up with a nice whole number. Okay? Let me explain this to you. If your number is really, really, really close to the number 1 or negative 1, you have a very high correlation. If it's a positive 1, it's a positive correlation, meaning that your line is going up. Can we agree? If you have a very close to a negative 1, that means that you have a negative correlation, which means that your line is going down. Is everybody okay with that? If you are closer to 0, then what that means is that you're closer to no correlation. I think, though, as a class, we need to make kind of a general rule. So again, this is just your positive correlations here. So again, close to a positive 1. The general rule that the PowerPoint here shows a correlation greater than 0.8 is generally described as a strong relationship. Whereas a correlation less than 0.5 is generally described as weak. So remember on Friday I said that. I split it down the middle and I said if we're above 0.5, we're close to 1. If we're below 0.5, we're close to 0. Does that make sense?
What about the middle?
What do you mean in the middle?
Like 0.6 and 0.7. Yeah.
So I would say this, I know that this says 0.8 says strong. What I would say is if it's above 0.5, it's strong, but it's just not as strong. Like you would still have the linear dots in it, it's just not going to be like a perfect line. Does that make sense? And that goes the same way for the negative. If we're at negative 0.5, then it's kind of right in the middle. So negative 0.6, 7, 8, and 9 is going to be a strong relationship. Negative 0.1, 0.2, 0.3, 0.4, I'm going to call it weak. Does everybody follow what I'm saying, or is this not making sense to you guys at all? We're good? Okay. I will tell you this, I made your test. Your test will not have any numbers. You'll have to put it into your calculator for the one question, but then it's going to just ask you to describe, is it a positive, strong relationship? Is it a negative, weak relationship? Those types of deals. Okay, so here we go. Right there, I've got a negative 0.4. Well, number 1, it's negative because there's a negative number in front of it. Can we see that? And it's weak because it's less than 0.5. Everybody okay there?
Yeah.
Okay. Right here we have 0.9. Number 1, this is positive because it's a positive number. And 0.9 is really, really, really close to 1 whole. So therefore, it's going to be a strong positive relationship. Negative 0.87, it's negative, which means our line's going down. Can we all agree with that? 0.87 is really close to a negative 1. So therefore, we're going to say this is a strong negative relationship. Does that make sense? Okay? So here are what a couple graphs look like. So it's telling me that R is equal to 0.7. And so this goes back to what Bennett was just asking me. Number 1, notice it's a positive value, which means this is going to be a positive line going up. 0.7, we agree, is above 0.5. So don't these dots look like they pretty much surround that line?
Yeah.
Okay. Over here we have 0.3, so we can agree that 0.3 is a positive relationship, but that because it's less than 0.5, all those dots are pretty scattered out. Which if we notice right here, yes, there's a line there, but if I took that line away, you wouldn't really see much of a line there. Is that fair? 0, there's no relationship at all. It is just straight random dots. 0 connection whatsoever. Negative 0.7, again, pretty close. It's a negative line, pretty strong. Negative 0.3, not much. And then again, 0, nothing there. Do the graphs help kind of connect it?
Yes.
All right, and the last one, they're just a couple more graphs. I don't remember what they described them with. So here is more, more specific. We can see, without the line going through it, negative 0.9, these dots are pretty close. We could pretty much see exactly where that line's going to go. Negative 0.5, I mean, we have an idea that it's negative because it's 0.5, but again, you're seeing that they're starting to get a little bit more spread out. It's when it's starting to get weak. 0, there's no line there. No linear relationship. Just like our warm-up, there's nothing there. Positive 0.5, again, you can see it's trending up, but not very well. Positive 0.9, and then 1, exactly 1 is just a perfect linear line. Cool? Good. All right, so then to summarize it all, let's just hit these high points real quick. The closer your correlation coefficient is to 1 or negative 1, the more linear your data is. When r is equal to 1, the data should be a perfect, straight, positive line. When it's equal to negative 1, it's a perfectly straight negative line. The closer the r value gets to 0 from either direction, negative or positive, the weaker it is. And when r is equal to 0, there is no correlation. And by correlation, I'm referring to there's no meaning to make neither of those calls. Okay? Are we all good there?
Sure.
All right, awesome. Okay, so with that being said, that ends my lesson for today. I'm going to stop the video recording and go to the next page. There are 6 questions. I'd like you to go ahead and work on them. Honestly, guys, you have 7 minutes left in class, meaning that you should probably be able to finish.